Okay, time for something that you should feel very familiar with. That's a juggling act, because I'm sure you're juggling a lot of things right now. Thank you for coming to my YouTube channel. All right, so this fellow named Bruce juggled 11 things at the same time, and all of these would be, they're balls that have the same mass of 0.2 kilograms. So that's nice because every single mass um, in this example is going to have the same mass of 0.2. But we're not going to deal with all 11 of those items. We're just going to deal with 2 of them. Okay, so you have a ball, and it's going to collide with another ball. They both have the same mass, m, and they're going to have a collision that is not perfectly inelastic, meaning these things are going to travel in the same direction, or not going to travel in the same direction. They're not sticking together. It says that it's elastic, meaning kinetic energy is conserved, and we could use that if we needed to. Actually, knowing that it's elastic would allow us to solve for 2 variables, not just 1, but you only have to do 1 here. It says the first ball is moving 3 meters per second to the right. The second ball is moving 4 meters per second to the left. One of these, they can't both be positive because these are velocities, so I'm going to call the left direction negative because that's what most people do. Okay, that is the initial or pre-collision state. And then finally, after they collide, so they're going to bump into each other, they still have mass of m, but the first ball whoops, oh, this is backwards. Ignore me. Okay, don't really ignore me, but first ball moves away from the collision. That's important. 3 meters per second to the right, which I'm still going to call positive. 4 meters per second to the left is where the other one goes. That's very important. Before the collision, the first ball was moving 4 meters per second to the left. Okay. Knowing a little bit about this, I can predict already what the velocity of the second ball is going to be before the collision. So this is the velocity of, I'll call this mass 1. Initial is what we don't know. Okay, so we're going to use conservation of momentum. The momentum initially, what is that equal to? It's equal to the mass of a ball times its velocity plus the mass of the other ball times its velocity. And it's equal to the final momentum, which is the mass of a ball times its velocity plus the mass of the other ball times its velocity. Mass times velocity is momentum. So there's only 2 things that have momentum in this example, and so we just add those 2 things up. You'll notice they all have mass in them, which it's fine if you plug that mass in of 0.2, but you don't have to. You can divide that number out. And so we have the initial velocity of one of those balls minus 4 is equal to -4 plus 3, -1. Add 4 to both sides. Surprise, surprise. The initial velocity of that ball is 3 meters per second, or 3.0, taking into account significant digits. All right, why does that make sense? Well, the total momentum has to be the same before and after. So if this one and this one are equal before and after, then this one and this one have to be equal before and after. So this is a much easier problem because they both have the same mass. If they had different masses, it would be a little tougher. But that's that.